All right, let's take a look at how we're going to balance chemical equations. And so the key thing here is we can only change the coefficients. We can't change any of the subscripts or anything. For example, saying H2O, oh, I need an extra oxygen, I'm just going to call it H2O2. No, we can't do that because these are two totally different compounds, right? Water and hydrogen peroxide are completely different. If you drink H2O, you're fine. If you drink H2O2, you're going to die. So we can only change the coefficients. The coefficients must be whole numbers. Right, so they can only be 1, 2, 3. You can't have 1.5 atoms or something like that. You can use that as an intermediate step, but at the end, all the coefficients must indeed be whole numbers. And then finally, the coefficients must be as low as possible. So what I mean by that, for example, if you had 3A going to 3B, that is not a properly balanced chemical equation because you can reduce that to a simpler number. Instead of having 3A going into 3B, you could have just A going into B, right? They say the same thing. So our numbers have to be as low as possible. And the way that we're going to balance chemical equations is just called by inspection. So we're just going to go step by step until the equation is balanced. There's other more mathematical ways to balance chemical equations, but overall, they're just really unnecessary. The vast majority of the time, chemical equations are relatively simple to balance. So let's take a look at this equation. So we're going to start off with a simple one. Water decomposes to hydrogen and oxygen. So we have to go from our sentence to a chemical equation. So the first thing that we have to recognize is that water is H2O. That is definitely something that you should know. If you don't know that water is H2O, now you do, and you should be good there for a while. And then decomposes, right? It's going to do something that indicates to us that we're going to go ahead and put our arrow. And in this case, it's going to decompose into hydrogen and oxygen. Remember, both hydrogen and oxygen are diatomic gases, so they don't just exist as H and O, they exist as H2 and O2. All right, so now we're going to try to balance this chemical equation. How you keep track of what's on each side is totally up to you. I'm going to show you the way I do it, but you can do it any way that you want to, as long as you get to the right answer at the end. So I'm going to put hydrogen, and then with two columns. On the left column is going to go with stuff on the reactants. On the right is going to go on the products. And then the same thing with oxygen. And those are my only two elements here. So when I take a look at my reactants, on the left side, I have an H2O. So that's 2 hydrogens and 1 oxygen. On the right side, I have an H2. That's 2 hydrogens. And then an oxygen, that's O2. Right. So the first thing that I notice is that I have less oxygens in my reactant side than I do my product side, which means I need to increase it. And what I need to do is I need to change this coefficient from a 1 to a 2. When I do that, I'm going to double the number of oxygens. But that's not all I'm going to do. I've also now doubled the number of hydrogens. So my reactant side, instead of having 2 hydrogens, now has 4 hydrogens. And you can tell overall it's not balanced. So now I need to add another coefficient. The thing that's not balanced is the hydrogens. I have 2, I need 4. So what I can do is put a 2 in front of this H2. Now on my product side, I have 4 hydrogens. And now we can tell that both of them are balanced, right? The hydrogens and the oxygens are balanced. And that's basically how you're going to do it. You're just going to go step by step. Obviously, this is a very simple example. We'll do another more difficult example, but the method stays the same. And then it's always good to double check. So 2H2O goes to 2H2 plus an O2. So I'm going to say always double check. And then in this case, for the double checking, I'm just going to draw a line right here. And then I'm going to say on the left side, I've got 4 hydrogens, and then I've got 2 oxygens. On the right side, I've got 4 hydrogens and 2 oxygens, which all checks out, and my equation is indeed balanced.